Now let's size the overcurrent protection device for the transformer that we just reviewed in figure 20-HC. Now let's size the overcurrent device for the primary. Now it's still kVA times 1,000 divided by the voltage. So we have a 450 kVA transformer times 1,000 divided by 13,800 times the square root of 3, and we derive a full load current rating of 18.83. Do you notice how when that voltage is high, how small the full load current rating will be? Note 2 then, referencing our table 450.3a for supervised location where the voltage is over 1,000 volts in the primary and secondary, we pick up 600% times 18.83, we come up with 112.9. And once again, we use our table 240.6a instead of the ANSI series to size our protected device for simplicity sake and fast referencing. And we come up with 110 amps because the note 3 to 410.3a, we have to round down from 112.9 to 110. So the solution is we'd have a overcurrent device rating using a circuit breaker of 110 amps. Now to size the overcurrent protection for the secondary and use fuses, then the calculation would be different, because we have 450 times 1,000, 4160 times the square root of 3, so the full load current rating would be 62.5. So the amount of amps for the full load current rating changes due to the voltage rating. Now in step 3, we reference table 450.3a and we pick up 250% for that secondary side. 250% of 62.5 produces a full load current rating of 156.3. And again, the note 3 to our table 450.3a for supervised location, we must round down from 156.3 to 150. And as previously stated, we're using our table 240.6a instead of actually going to our ANSI standard, C standard, to pick up. I think it's C37 that we quoted in the illustration to you. And it would be C37.06 for circuit breakers, fuses C37.46. So the solution then for the secondary would be 150 amp fuses, and for the primary it would be 110 amp circuit breakers if we selected in accordance with the NEC. So that's what our figure 20.8C, or excuse me, 20-8C is illustrating to us.